All right. First video this week, October 12th, Monday. We had a little bit of a talking to today, so make sure you are looking for the secret thing or whatever it is. Dog hair. I tell you about later on in the video. Tomorrow, on Tuesday, we'll be talking about convection currents. And we'll also be practicing on Quizlet, so make sure that you have that ready to go tomorrow. We'll be able to get into there, practice on that a bit, and study for this week's quiz. So convection currents. We've talked about these before. Very simple, very easy thing to discuss, because we should have, you've heard about them forever. We talked about them in probably 5th grade, 6th grade, and we talked about them a little bit earlier in the year and today. And a convection current is just simply a liquid that has been heated, and it just causes that liquid where it's getting heated at, like right here, for example, in the mantle. This right here, this molten rock, is much closer to the heat source, so it's getting hotter faster than the stuff up here. Okay, that causes this liquid rock to rise up. Okay. And when it does that, it pushes the stuff that was right here this way. Okay? And that in turn causes the stuff that was where this is to get pushed down this way. And it just goes in a circle like that, over and over and over, constantly heating up, rising, cooling off at the surface because there's no heat source up here. It loses heat. And then it drops back down once it cools off. Okay, and it's constantly being forced into this circular motion all the time. It's constantly happening. It's happening right now. It's been happening for millions of years. Okay, especially in the mantle. And it's happening. All right, so clear all drawings. Exit that. All right, that's the mantle. Okay, inside the Earth. Now, for wind, because we're really talking about weather in this unit. And so it'd be weird if we didn't talk about the convection cells around our planet. See, it says polar cells, Ferrell, not like Will Ferrell, the comedian, or I don't know who had Loopy. That's just the name. Probably the person that discovered them, I assume. That's usually how things are named. When you discover something, you name it. But this area here, around the equator, you see how it's kind of colored red a little bit? That's because it's warmer than the rest. And so this area getting warmed by the sun all the time causes heat to rise up, because we know heat rises. And so that makes the air hot. The air rises up, okay? Rises up and it starts moving in this circle, just like how it was before in the mantle. The stuff that's heated up by the heat source, which in this case is the ground, because the ground absorbs heat, like similar to how like blacktop, like the street, like a parking lot, gets really hot in the summertime, absorbs heat really well. Surface of the Earth absorbs heat really well, okay? And it heats up the air above it, just like on a stove, okay? And that air rises up, and it goes in this circle. Same thing, it goes up, pushes the cooler air out of the way, and that cooler air sinks down. All right. Now here, right here, where it says sinking air right there, some of this heat gets transferred over to this one. Just a little bit, not a lot. And it helps to drive this convection current as well. We all know, obviously, that the sun is striking the Earth in an uneven way. It's hitting here at the equator more directly, more often, all the time. It's hitting there at the equator, straight on. So the equator is the hottest. It's hitting up here too, but just not as much because it's at an angle. So it's hitting not as direct. Okay, and then same thing up here, even more so. It's at more of an angle, so it's even less direct up here. So it's getting less energy, and so that's why these are blue. It's cold air, but it's still being warmed by the surface of the Earth, causing this convection current. Okay, so that the wind up here is driven by such a much smaller amount of heat. Okay, so these are probably weaker than the ones around here because these have the most energy. These have the least. Okay, so these are called convection cells, and they're in our atmosphere. They're what cause these global winds, trade winds, westerlies and easterlies. These spinning around and the turn of the Earth, the Coriolis effect, cause these winds to curve. You can see these arrows are curved. Okay, and now we'll move on to the last section here. The secret code for today, by the way, is my favorite number. It is 343. And you might ask, man, mister, that's a really weird number to like. I really, really like Halo, and there's a character in Halo named 343 Guilty Spark, and he's a little robot ball that floats around and follows you sometimes. So you're going to take that information, 343, Mister's favorite number, and you're going to take it, and you're going to go put it over here. You're going to put it like right here. Mister's I can't spell favorite number is 343. And if you want to say because it's from Halo, that's fine too. But if you put, not Mister's favorite number is 343, you put that there, and I will mark you down as having watched the video. I know you've done it. You get this extra bonus point, or lack thereof if you don't watch this, in which case you won't even know I'm talking about you because you're not watching the video right now. So, now back to the other thing. So we're going to go back here. We're going to go to these ocean currents this time. Okay, ocean currents, similar, a little different, but still basically the same. I'm going to go yellow this time. So the water gets heated up at the surface, right? Because that's where the sun's hitting. The sun doesn't hit the super duper deep ocean, right? That'd be kind of weird. But the warm, again, the equator line here is getting beat by the sun all day long. The sun is hitting the ocean there all day, all the time, every single day of the year. So this area of the water is much, much warmer. If you've ever been swimming like over here, like in Cuba, probably not Cuba because it's just whatever, by Florida, we'll say, the water by Florida is really warm, okay? And so this water in this area, you see most of these arrows are red. So this water circulates and goes south, or circulates and goes north towards the cold, which is up here and down here, okay? So these circulate that way. It goes like that, but it also goes down, okay? So it also will cool. So once this warm water goes down past a certain point on the Earth and it's cooled off enough, it sinks down underwater, okay? And then it eventually gets pushed out of the way and rises back up over here and warms, all right? And this forms these currents. We talked a little bit today in fifth hour. I mentioned about the, from Finding Nemo, the East Australian current with the turtles, bros. Like, squirt, and dude, like, those turtles ride this current because it's free, like, you just move. That you don't have to do anything, right? It's very effortless to move very quickly over long distances. And like you said, you probably can't, if you were underwater, you can't just say, oh man, look, there it is. You can't really see it like you can in the movie, I don't think. Maybe you can, I have no idea. I've never been out into the ocean like that. But these currents happen, okay? They get hot here, or hot, warm, here near the equator, and then they sink down south or rise up north towards the cold water, cool off, and then they sink down underwater back towards the equator. And then they rise up again because the water at the surface has been heated and moves away. So it pulls this cold water up towards the surface to get warm. Okay? So that's convection. Again, you've heard about it a long time, many years now, and you're still going to keep hearing about it. That's how all of school works. You start out with little baby basics that you learn in first grade, and then you build on it, you build on it, you build on it, like a never-ending Lego set that is way less fun than actual Legos. All right. If you enjoyed this video, standard YouTuber outro, slap like and subscribe and leave a comment. Turn on the bell for notifications and stuff so that you don't miss any content. And I will see you guys tomorrow.